You guys have already seen radicals. That was the square root symbol that we were using in chapter 9 when we were solving by square roots and when we were using the quadratic formula. But what we're going to do now is we're going to use what's called simplifying a radical expression. You'll be able to use your calculator, ladies and gentlemen, but you will not be taking square roots on your calculator. So we'll show you what your answers should look like. So there's some rules that we have to follow. If a radical is simplified, it means that there's no decimal answer. So if you remember back in chapter 9 when we took the square root of 5, we got that 2.24 blah, 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 blah. We got that long decimal answer. You cannot give me any decimal answers. You can't leave a pair of factors under the radical. So you can't leave 2 times 2 under the radical. You can't leave 3 times 3 under the radical. There can't be fractions in the radical, and there can't be a radical in the denominator. These last 2 rules we'll focus more on tomorrow. So these first 2 are what we're going to work on understanding, recognizing, and using in today's lesson. So what we're going to do, ladies and gentlemen, is we're going to simplify something like the square root of 45. Simplifying the square root of 45 means you're going to find pairs of factors that are under there and take that out. So to start with that, we're going to start by taking a factor tree. How many of you guys remember making factor trees back in like 4th grade or 5th grade when you were looking for like common multiples or common denominators? So when we start with the factor tree, we're going to take 45 and we're going to break it up into 2 factors. I like 5 times 9. Anything that ends in a 5, I usually divide by 5, unless I know something else. What I'm looking for when I have a square root, guys, is I'm looking for a perfect square. And a perfect square is when we have a number multiplied by itself. So when we have that pair of factors. So when I look here, I know 9 is a perfect square because I can break that down into what? 3 times 3. And so there's that second rule, guys. It says no pairs of factors underneath the radical. We found a pair of factors. I usually circle that because that has to stand out to me. That's what I was looking for. And I have to take that out from the radical. When I find a pair of 3's, guys, I'm taking the square root of that, which means 3 is going to come out. Because what's the square root of 9? 3. Now this 5 is not a perfect square. It doesn't have a pair of factors to go with it. It's just a single 5. And so if it's a single 5, it's going to stay under the radical. And so this is what a simplified radical looks like. You found, that's it. You found the perfect square 9. You broke it up into its pair of factors. The square root of 9 is that 3, and so that 3 comes out, and anything single stays under there. So now how do I know that that's the correct answer? I'm going to grab my calculator. And when I grab my calculator, I'm going to type in square root of 45. And I think I can switch to the document camera on here. I'm not going to it because it might mess up the recording, guys. Sorry. Square root of 45 and hit enter. I get that long decimal again. Remember, we knew we were going to get something that was irrational. But now I'm going to type in 3. And I'm going to type in square root of 5. I'm going to take this answer that I just got. And when I hit enter, what do I get? The same thing. And that's all we're doing, guys. It's kind of similar to like if I gave you the fraction 4/8. If I asked you to simplify 4/8, what would you call that? If I give you 4/8, what would you simplify that down to? 1/2. And if you typed both those into your calculator, ladies and gentlemen, would you get the exact same decimal value? Yeah, we've just gotten rid of that common factor of 4. You're getting rid of that perfect square 9 that's underneath that radical. All right, let's try 150. What do we think we could break 150 into? Something quick and easy? 10 and 15, that's exactly what my brain was thinking because anything that ends in a 0, guess what I divide it by? 10. No, you can't divide by 0. All right, now I'm going to break this up because these both can be simplified. 5 is what we call a prime number, guys, so I knew 5 couldn't go any farther. But anything that's not prime, I want to keep breaking it down. What can 10 break down into? 2 and 5. And what can 15 break down into? 3 and 5. Now, ladies and gentlemen, I'm going to write it as 5 times 3. Does anyone know why I might write it in that order? Because you're looking for a pair of factors, correct, guys? And right now, my 5s are right by each other. Even though I didn't put the number 25 underneath the radical, and I could have done 25 times 6, because that's the same as 150, when I end up with 2 5s, it's still a pair of factors regardless of where it came from. Now the 2 doesn't have anything to pair up with, and the 3 doesn't have anything to pair up with. What's 5 times 5? 25. And what's the square root of 25? 5. So that 5 is what's going to come out from underneath the radical. Now I still have a 2 and a 3 here. What's the only operation that you guys see underneath this factor tree? What's the only operation that we use? Multiplication. So guess what you're going to have to do with the 2 and the 3? Multiply them. 2 times 3 is 6. If we're still trying to check and make sure we're doing things right, guys, I'd grab my calculator. Second square root of 150. Once again, you're going to get that irrational decimal. Then I'm going to do 5. Square root of 6. Breathe a sigh of relief. Did we get the exact same decimal? Yep, we're doing it right. Okay, ladies and gentlemen, let me grab my note packet because I feel like... All right, example 3 and example 4. All right, what's different here with example 3? There's a number out front, and we read this, ladies and gentlemen, as 3 times the square root of 50. So we're going to do exactly what we did before. We're going to simplify that square root of 50, but now we have to multiply by 3 at the end. So I usually take that 3, and I just write it somewhere over here so I don't forget about it. But now I'm going to take 50, and I'm going to break that up. What do we want to break 50 up into?
5 and 10.
5 and 10, 25 and 2. Could you have done either one of those? You sure could. But 10, what do I know I have to break 10 into now? 5 and 2. And no matter how far apart that pair of 5s is, guys, it's still a pair of factors underneath the radical. Anytime you have 2 of the same number, they're considered a pair of factors. 2 is prime, it can't break down, and it's all by itself. There's no other 2's. So what's 5 times 5? 25. And what's the square root of 25? 5. So I know I'm going to have 5 outside of the radical. What's going to have to stay under the radical? The number by itself, which is 2. But then what did we still have out front here? 3. And remember, guys, this is 3 times. That's the only operation we're going to be using today. So what's 3 times 5? 15. So our final answer is 15. Square root of 2. Feeling okay here, guys? All right, one last one. 80, we can break it up multiple ways. Once again, it just depends on how sharp you're feeling with your multiplication facts. But right now, 8 times 10 is the first thing that comes to mind for me. I'm going to do 2 times 4 for the 8. And I usually keep going there because I know I've got a 2 times a 2 there. What is 10 going to be? 5 and 2. And so now we've got all these numbers. There's this large factor tree that we have. I'm looking at the ends of the factors. I'm not looking at the 4. I'm not looking at the 8. I'm not looking at the 10. I'm looking at the end of the factor tree. There's only one 5, so I'm going to underline that because I know it's going to have to stay underneath the radical. But now I'm going to start looking at how I can pair these 2's up. There's one pair of 2's over here. And I can only make pairs, guys. I'm looking for perfect squares. And square means a number times itself. Not a number times itself 3 times. It's 2 2's multiplied together. It's 2 5's multiplied together. But this 2 isn't alone, is it, guys? Is there another 2 we can pair it up with? Yeah. Even though it's way over here, guys, I can still pair those 2's up. You're not looking for pairs that necessarily came from the same factors that you broke up. They're just 2 factors underneath that radical. Because remember, guys, we didn't have to start 8 and 10. We could have started with some other set of factors of 80. But when I look under there, guys, I still have that 5 that's going to be underneath my radical. 2 times 2 is 4, and the square root of that is 2. 2 times 2 is 4, and the square root of that is 2. This is the first time, give me just a minute here, guys, like my equal sign is too close. This is the first time that we've pulled 2 set of factors out. And so when I pull those out, it's just another multiplication. So 2 times 2 is 4, the square root of that was 2. 2 times 2 is 4, and the square root of that is 2. But then don't forget, guys, what did we have out in front of this problem from the very beginning? We had a 4. So now we've got 3 terms outside that radical that we need to multiply together. 4 times 2 times 2 is going to give me 16. Square root of 5. I believe you guys have 2 on your own at the bottom of the page. Am I correct? Get started on those, please and thank you. When you're done, ladies and gentlemen, check them on your calculator. Type in square root of 90, type in your answer, and then compare answers with your table mates. And you don't need a graphing calculator to check these, you just need something that does square roots. Now, I will say, ladies and gentlemen, when you disagree with the table mate or you disagree with my answer, it is difficult to find your mistakes because it all depends on how you started that first factor, like the first set of factors you used for 90. How did you break up that 90? How are you breaking up that 200? It's difficult to find your mistakes, but it's easy to figure out when something is wrong because when it doesn't match on the calculator, then you know that it's wrong. So, are you guys ready to compare your answers at your table? Are we still doing a little bit of work? Okay, give you a little bit more time to work. These are some of my favorite problems. Because it's just like math, it's not like algebra. Ladies and gentlemen, let's take a look at the answers at the board. Now, ladies and gentlemen, it is okay if that is not what you did, if that's what's coming out of your mouth. If you said that's not what I got, then we need to start trying to find where some mistakes are at and make sure we're asking questions while we work. But I want you guys to take a look at what I did with A. I broke it up into 9 and 10. We talked about that something that ends in 0, dividing that by that 10 is pretty nice. 9 is a perfect square, so it immediately went into a pair of factors. And so 3 times 3, I could circle those. 10 is 2 and 5, and there was no pair there. So I did 2 times 5. Those single numbers get multiplied together. 3 times 3 is a perfect square of 9, and the square root of 9 is 3. So are we okay with the 3 square root of 10 there, guys? All right. Now let's take a look at what I did on number 5. I started up thinking, oh, I'll divide by 10. And do 20 times 10, but then I stopped, ladies and gentlemen, and I decided to divide by 100. Because one thing I know about the number 100 is it is a perfect square. So if I can find a perfect square that is divisible, that is one of the factors, I'm going to go there. Because instead of making a big, long factor tree, what was I able to break 100 into right away? 10 times 10. And remember, guys, what you're looking for are pairs of factors. You're not looking for prime numbers. You're looking for pairs of factors. So I can stop my factor tree early as soon as I find that pair of factors. 10 times 10 this is 100, and the square root of that is 10. That pair comes out as a single 10. The 5 carries it over, and then the only thing that's left under there is that single 2. Drew.
I do
Different numbers under the factor tree?
Yeah.
And still get the same answer? That's perfectly fine.
For every single?
Yeah. Some numbers there would only be one way to break. Like there's going to be a very common way to break it up. For some of those, I'll watch. There are some numbers that will always get broken up the same way. But something like 200 gets broken up a bunch of different ways. Some people do 50 and 4. Some people do 2 and 100. Some people do 20 and 10. There's lots of different ways you can break them up. But the one thing we know about numbers is 200 always has the same set of prime factors regardless of how you start, which means even if you took every number down to all of its prime factors, you would still find those same pairs that I'm finding with the 10 times 10. You should have found a pair of 5s and a pair of 2s, am I correct? If you broke it all the way down, guys? And that 5 times 2 gives you the 10 there. I thought I saw another hand. Dylan. So what I'm going to guess, thank you, is waiting for someone to do that. Remember I said to check. What happens, guys, is sometimes you can get an answer that matches this, but what happens is if I look at the number you have under the radical, it still breaks down. Do you by any chance have 20 under your radical? You have 8. Does 8 break down? And this is important for everyone. 8 does break down. What does 8 break down into? 4 and 2. And 4 breaks down into 2 and 2. So what happened is Dylan had the right number, but I bet if he pulls a 2 out, or I'm going to guess you have 25 square root of 8, am I correct? And if you find that missing pair of 2's there, that's going to give you the 50. So what you have to be really careful of, guys, is that when you stop breaking something down, that you stop at either a pair of factors or you stop at a prime number. Okay? But what's going to happen is the calculator check won't catch a mistake like this. It just catches mental math mistakes or putting the wrong number on the outside versus the inside. So just always double check what's under here and see if it would break down any farther. All right. Ladies and gentlemen, can you turn to the back side? What's on the back side? More multiplication with these. So now we've got a radical times a radical. What are we going to do with those, ladies and gentlemen? We're going to multiply what I call like terms. We're going to take the numbers on the outside and multiply those together. So what is 2 times 3? 6. And then I'm going to take the numbers underneath the radical, and I'm going to multiply those together. What's 8 times 10? 80. Now, ladies and gentlemen, you've got a couple of options. You can call it 8 times 10 and call it 80. Or you can just leave it as 8 times 10. Because what are we going to end up doing with that 80 anyways, guys? We're going to be breaking it down into probably 8 times 10 anyways. So the numbers underneath the radical can stay separate as a multiplication problem. And that just means you got a jump start on your factor tree. So now I'm going to try and break things down. I'm going to break this 8 down into 4 times 2. Because I know that this 10 also has a 2 hiding in it, right, guys? So I knew I could find a pair of 2's. But what am I going to have to remember to do with this 4? Break it down. It's not a prime number, so I need to break it down into 2 times 2. So I found a second pair of factors. I have the 6 that was on the outside from that original multiplication. I have 1, 2 that I pulled out from that first pair. And then I have a second 2 that I'm pulling out from this middle pair. And then the 5 is all by itself. Remember, even though there's a 4 and an 8 and a 10 under there, guys, those don't exist because you're only looking at the bottom of the factor tree. I've got to do this multiplication outside. 6 times 2 is 12, times 2 is 24. Square roots of 5. And then number 6, I'm basically going to do it the same way. That's another reason I like these problems, guys, is they can develop a really nice routine. Multiply outside times outside and get 6. And then take the numbers underneath the radical and write those together. I'm going to write this as 7 times 28. There's a couple of reasons I leave it as 7 times 28. I can't do that in my head. I could have done 8 times 10 pretty easy in my head. I can't do 7 times 28 in my head. I'm going to get something like, I really don't even know, 196 I think is what it is. I don't want to get 196 because then I have to think about what divides into 196. I'm going to leave it as 7 times 28. And I really like this because what could I break 28 into? What would be a good thing to break 28 into? 4 and 7. I like that a lot because, ladies and gentlemen, here's my pair of 7s, correct? Now, what are we going to have to do with 4? Break it down into 2 times 2. Beautiful. What do I have left underneath the radical? I had a 4, but did we break the 4 down? Yeah. So the 4 doesn't exist. The 28 doesn't exist. I'm going to go with what Drew said. You've got nothing left underneath the radical, do we, guys? There's no single number, because guess what? 196 is a perfect square. And that will happen sometimes, guys, and that's okay. But you're going to recognize your perfect squares because everything will pair up. So what's your final answer going to look like? Your final answer is going to be this 6 that we got from the 2 times 3. We're going to multiply it by 7 from this pair of 7s, and we're going to multiply it by 2 from this pair of 2s. So 6 times 7 is 42, times 2 is 84. Does someone want to double check my math? No, that's right. Ladies and gentlemen, I believe you got 2 on your own. I'm going to have you guys do those. Once you have 2 good answers, I want you to raise your hand, and I'll come around and check those. Actually, guys, we're going to change that. I'm going to give you some time to work, and then I'll put answers on the board because my 5th hour needs to see the answers. So keep working at your tables. Raise your hand if you got questions. Remember, outside times outside, inside times inside, and then break it down to look for your pairs. Alright, ladies and gentlemen, let's take a look. For the first one, I just have one number outside the radical, so it's just going to stay 2. But then I have 5 times 10. 10 quickly breaks into 5 times 2, so there's my pair of factors. Remember, the pair of factors is what comes outside, so this is going to be 2 times 5. And then the numbers that I underline, the single ones, are what stay under the radical. So it's going to be square root of 2. 2 times 5 gives me 10. So we should have 10 square roots of 2. How do we feel about that answer? Pretty good? Awesome. 3 times 2 is 6. And then I'm going to break 6 times 6 underneath the radical. And then notice, what did I do right away, ladies and gentlemen? I just circled them. Because what am I looking for underneath that radical? I'm looking for a pair of factors, and I found a pair of 6s. Now, could you break that down into 3 times 2 and 3 times 2? Yeah, and find a pair of 3s, and find a pair of 2s. You could, ladies and gentlemen, and that is awesome. But remember, you're simply looking for a pair. It doesn't matter how big or how small those pairs are. It's just a pair of factors. So I'm going to have 6 on the outside this pair of 6's comes out, and so your final answer is 6 times 6, 36. How did we do, guys? Nice. All right, I'm going to hand out today's worksheet and get you guys started on that.